Hi, Algebra 2 students. We are going to round out the chapter with section 6.8, the Rational Zero Theorem. And this is where it all comes together. Our objectives: identify possible rational zeros of a polynomial function. Notice it says possible rational zeros. And then the other objective is find all of the rational zeros of a polynomial function. So not just identify the possibles, but determine which one of those are the actual rational zeros. Vocabulary is rational zeros, and we have the Rational Zero Theorem. It helps us simplify the process of hunting for zeros. And the Rational Zero Theorem says that if you have a polynomial function f of x with integer coefficients, whoops, sorry about that, then p over q, or the fraction p over q, is a rational zero in simplest forms of y is equal to f of x. Then p is a factor of the constant term of f of x, and q is a factor of the leading coefficient. 1 and -1 are always factors of the constant term and the leading coefficient. 1 and -1 will always be possible zeros. The corollary to that: if the constant term of a polynomial function is not equal to 0 and the leading coefficient is 1, then any rational zeros of the function are factors of the constant coefficient. Okay, so what does all of that mean? Well, let's take a look at some examples to help us out. What we want to do is list all of the possible rational zeros of the following functions. So let's take a look. We have a function f of x that's equal to 3x to the 4th power minus x cubed plus 4. So all of the numbers that we're going to call p are the factors of the constant term. Our constant term is 4. So what are the numbers that are factors of 4? Well, we have plus or minus 1, we have plus or minus 2, and we have plus or minus 4. Those are all the different numbers that we can use to multiply, integer numbers that we can multiply to get the number 4. What about the numbers q? List all of the factors of the leading coefficient. Our highest degree term is 3x to the 4th. Our polynomial is of degree 4. The leading coefficient is 3. So what are all the possible factors of the number 3? Well, we have plus or minus 1, and we have plus or minus 3. Okay, so far so good. Now what we're going to do is we're going to list all of the possible combinations of the numbers p over q. So that means we're going to take all of the numbers on the p list and all of the numbers on the q list and combine them. So we're going to have plus or minus 1 over 1, which is 1, plus or minus 2 over 1, which is 2. Then, and all of these are always going to be plus or minus 4 over 1, which is 4. And now we get into the over 3s, because we did the over 4s. I'm sorry, the over 1s. Now we're going to do the over 3s. So we're going to have plus or minus 1/3, plus or minus 2/3, and plus or minus 4/3. Now we have all of the possible combinations of the numbers p over q. We're going to do the same thing with example number 2. And we're going to list them out. So the p's are going to be plus or minus, remember this is for the constant term. Our constant term is this number -15. So all the numbers that we can multiply to get -15. So plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. Those are all of the numbers p, factors of the constant term. Now let's find all the numbers q, plus or minus, and again, these are the factors of the leading coefficient. So that's plus or minus 1, and that's it. Whoops, that's it. Okay, when it comes to the p over q ratio, we have to combine all of the possibles. Since we only have q as plus or minus 1, that means that our p over q is going to be the same as our p list, plus or minus 1, plus or minus 3, plus or minus 5, and plus or minus 15. All right, that was for example number 2. Now we're going to work on example number 3 and do the same thing. So our constant term is negative 8. What are all the factors of negative 8? We could have plus or minus 1, plus or minus 2, plus or minus 4, and then plus or minus 8. Next is the q's. So for the q's, our leading coefficient is 3. So we have plus or minus 1, plus or minus 3. Last of all, we have the p over q numbers, where we're combining each of the p's with each of the q's as a denominator. And so we're going to do over 1 first. So we're going to have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Now we're going to do the over 3's. So plus or minus 1 over 3, plus or minus 2 over 3, plus or minus 4 over 3, and plus or minus 8 over 3. And that is the full list of all the possible combinations of the numbers p over q. Now, why are we doing this again? Oh, yes, because these are the possible rational zeros of the polynomial function. All right, we've got an example number 4, and this says find all of the zeros of the following functions. For number 4, f of x is equal to 3x cubed minus 2x squared minus 8x plus 5. So we're going to start this in turn. First thing that we're going to do is we're going to use Descartes' rule of signs. Find the number of positive real zeros and the number of negative real zeros and make that little chart so we know how many we're looking for. Then we're going to do the p's and q's using the constant for the p's, the leading coefficient for the q's, all of the ratios of p over q. And then what we're going to do is we're going to start testing using synthetic division all of the p over q numbers in the box. Why? Because we want to find a depressed polynomial. We want to find remainder equal to 0, and that means that we have found a factor of the function, and we have found, therefore, a root of the function. So let's start at the beginning. Let's find the number of positive and negative real zeros and set up the little chart. Turn the video back on when you've done that much. Okay, so we found the number of positive, negative, and imaginary zeros that we're anticipating. The next thing that we're going to do is using these p's and q's, we know that the factors of the constant term are plus or minus 1 and plus or minus 5. We know that the factors of the leading coefficient are plus or minus 1, plus or minus 3. And the p over q terms that we're going to be working with, therefore, are going to be plus or minus 1, plus or minus 5, plus or minus 1/3, and plus or minus 5/3. Okay, now we're ready to start with the synthetic division. So what we're going to do is we're going to start with one of those rational terms, and we're looking for a remainder of 0 to tell us that we actually found a factor and therefore a root of the polynomial. So let's set up the synthetic division with x equal to 1. Now on this example we're actually going to go through a few more than we need to because we usually have a little bit of intuition about which ones we're looking for, but I want to show you how it's done and how we eliminate. So when x is equal to 1, we set up the synthetic division and we run through the numbers. I know that you're familiar with this, so I'm not going to spend a lot of time on it. In this case we found a remainder equals to -2, and so we know that the remainder therefore is not equal to 0, and we have not found a factor. So let's try another one. Let's try -1. So we'll put -1 inside the box this time. Set up the coefficients, and okay, so once again, we found a remainder that is not equal to 0. Okay, so we need to try some other numbers. The next number that we're going to try, we'll try 5, and then we'll try -5. These are all from our p over q list. So we tried these Now we're going to try a positive 5 and negative 5. So let's set those up. We'll put 5 inside the box, and again with the coefficients. Okay, this remainder is definitely not equal to 0. Let's try negative 5 inside the box this time. Okay, so we tried positive 5 and negative 5. We know that none of those are roots, so we're going to try the next numbers, which are going to be positive and negative 1/3. Go ahead and pause the video, set that up, and run through positive 1/3 and negative 1/3 inside the box. Okay, so as we ran through positive 1/3 and negative 1/3, we found that neither one of those gave us a remainder equal to 0. So we're down to our last two possible rational zeros, and that is positive and negative 5/3. So what we're going to do is we're going to set those up inside the box. Okay, so with positive 5/3, we're working through the synthetic division, and we hit the jackpot. We have a remainder equal to 0. So what this means is our depressed polynomial is what we're going to work with next. We don't need to work the negative 5/3 angle because we now have a depressed polynomial. We know this is the remainder, this is the constant, this is the x term, this is the x squared term. So what we have is 3x squared plus 3x minus 3. Remember that we have a remainder of 0, but what we ended up having with this depressed polynomial is we set this equal to 0 because we found a factor. X is equal to 5/3, which means that if we pull it over to the other side, x minus 5/3 equals 0 is our factor. Now we're looking for the other factor. What we need to do is we need to simplify this. So we're going to factor out that 3, and we're going to end up with x squared plus x minus 1 is equal to 0. At this point, we're going into the quadratic formula so that we can find the other roots. Pause the video, put those coefficients in the quadratic formula, and turn it back on when you're ready to check your work. Okay, so what actually ended up happening is we ended up having 3 roots, which we knew we were going to have. One of them is, or I should say, there's our first one. There is our second one. And there's our third one. So we have 2 positive and 1 negative real roots, or zeros. Now, the next example, number 6, is modeled after this one. I don't know, does yours say number 6? Let's see. Okay, number 5. We have 2 more examples, number 5 and number 6. Turn the video off, practice those, and then turn the video back on when you're ready to check your answers. Okay, so we tried 1 and negative 1 in the box, and we ended up finding a remainder equal to 0. So this is going to give us the depressed polynomial that we need to lead us into the next step. So once we come up with a depressed polynomial, this is the constant, the x squared, and the x cubed, we have 2x cubed